like what it says, I told you. Last week's results we analyzed today, that's what I referred to there. So the plasma transformation stuff, we went over the UV stuff, you need to know that.
For the white blood cells, just do all of the ones that are basically folded, or like in the pictures?
Yeah, in the figures. Neutrophils, and there's a mnemonic, and the mnemonic tells you the percentages, but it'll help you remember just the names as well. Never let monkeys eat bananas. Never let monkeys eat bananas. Never is neutrophils. Let is lymphocytes. Monkeys, monocytes. Eat, eosinophils. Bananas, basophils. Never let monkeys eat bananas. That also tells you the percentages from high to low, which you'll need to know for lecture, starting with neutrophil. That's the most abundant in a healthy person.
Do we need to know agranular?
No. Agranular, is that?
Yeah.
No. For lab, just the names. For lecture, a little bit more. You won't need to know that. Know the purpose of all the lab experiments. Again, it's just general concept, like it's the headings of the titles of the lab's experiments. The purpose, the Snyder test was for testing for cavities. ELISA, testing for antibodies against a certain disease. It's just basic concepts. And again, the quizzes, it's just quiz 5 and 6. 1 through 4 was on the first half. It's not cumulative, it's just the second half of the lab. So go back and study your quiz 5 and 6 material. Week 7 and 8. Know the following specifics for each media / tech. If I don't finish this, I'll finish it in lecture. Don't get worried if we start running out of time. Know the following specifics for each media. Oh, let me back up. The setup is going to be the same as the midterm. So you're going to be timed. There's going to be 50 questions, 2 questions per station, 2 minutes per station. Most of them are one-word answers. You know, very, very similar setup. We'll probably be across the hall somewhere. I don't like having them in this room or the other room. So where did we have it last time?
In the hall.
Down all the way around in the corner. Yeah, I don't like that one either. It's so long. So I'll let you know. Just come up, and I'll probably let you know in lecture on Monday. It's going to be on Monday, 1 week from today, and I'll tell you the exact time. Probably in lecture on Monday. So make sure you come to lecture on Monday. It might not be right at 10 o'clock. Or maybe it will. Week 7 and 8. Know the following specifics for each media / test. See also biochemical tests for identification of microbes list from my website. That's another document you should have printed out. Can you read? Do I need to make that bigger?
Yeah.
I think so, yeah.
Good job.
There we go. Sorry. So, the biochemical tests for identification of microbes list. I've already downloaded that. You just got to memorize it. Got to memorize. It's all there for you. Just got to memorize it. Let me sort of break it down as to what you're looking at.
Holy crap.
So the title here is Biochemical Tests for Identification of Microbes. You did lots of inoculations of biochemical of media for biochemical testing purposes. And now notice here I have, I'm sorry. So biochemical tests for identification of microbes. Can you see that? And then this is a column right here. Name of medium / test. That's a column. All this is underneath that. positive column right there, negative column, pH indicator reagent column. This here says tests used to identify your gram-negative unknown. That's part of the first column. I should have brought this over. That made like one thing. So that's one column right there. Now, you don't need to know, let me make this clear. You don't need to know, you need to know all of the biochemical tests. You don't need to know which ones we actually used specifically to identify your unknown. All of those tests you use to identify your unknown are listed in this column under name of medium / test. But there's also some other ones there. So I just put this in there, but you don't, I'm not going to distinguish which one did you use to study to test for your unknown. Don't worry about that. It's just to refresh your memory that you used a bunch of these to identify your unknown. Okay? You just need to, basically you just need to know everything on the table. But you don't need to distinguish, I won't be distinguishing between what you used to identify your unknown and what you didn't. Okay? So here's a bunch of tests. These are the fermentation tests, the sugar fermentation tests for sucrose, glucose, and xylose. You need to know PRS, it stands for phenol red sucrose, PRG, phenol red glucose. These are sugar fermentation tests. We did a lot of those, you know the concept of that. I want you to know, actually let me go on first. You need to know what a positive result looks like. So for each of these, if it turns yellow, it's positive for what? Fermentation of the particular sugar, sucrose, glucose, xylose, respectively. If there's no color change, meaning it stays red, that's negative. You need to know what the pH indicator is in all of these. It's phenol red. The reagent, a reagent is something you add. And I'm going to tell you, some of these are reagents, some are stuff you add, some are just pH indicators as part of the medium itself. Phenol red's a pH indicator. I do want you to know, with regard to these three here, that you get this positive result and it turns yellow under acidic conditions, which you do know that already. So make sure you know that, mark it down if you need to. When it's an acidic environment, it turns yellow. And yellow means positive. Acidic environment. Now, let's jump down to urease. Right here, urease. The urease, I didn't mention this when we actually used it, it also has phenol red in it, but a positive result for this, it turns pink. And that occurs under an alkaline environment. You need to know that. Under an alkaline or basic environment, same thing, alkaline. In other words, phenol red turns pink under alkaline environment. And so on. And I'll come back to this in a little bit. Let me go back to the other. Any questions before I go back? So that's this. Know the reagents used in all the biochemical tests performed. The reagents were the substances that you added to the media. Know the pH indicators in the various media used. Okay, so that's just, you got to go to the list. Let me go back. So let me tell you right now which ones were actually part of the medium, the pH indicator, and which are the reagents that you added. And just put down P or R for time's sake. Don't write out the whole thing next to the word. So phenol red, they're pH indicators. If you write it, just put a P or a PI. Kovacs, reagent, just put R. Methyl red, it happens to be both. It's both a pH indicator and it's something you added, so it's a reagent. Baratane B, reagent. Monomethyl blue, pH indicator. Phenol red, pH indicator. Ferric chloride, reagent. You added that. Hydrogen peroxide, reagent. Nitrate ABC, reagent. Remember, nitrate C is zinc. Chrompressor green, pH indicator. So you used all that. You either added it or it was inside read. Yes.
Did you say hydrogen peroxide was a reagent?
That's a reagent.
Okay.
You added it. You added it for testing purposes.
I'm sorry. That's A and B is
Correct. Any other questions?
Repeat it.
Number 3. What indicates a positive reaction? You need to know what indicates a positive reaction. Question? What indicates a positive reaction for the various biochemical tests performed? For example, a color change to yellow, like for the fermentation, positive. Gas production might be positive. Bubbles form might be positive. It depends on the test. How do you know? You have to study the table. So yellow for these tests. Indole, after you added Kovacs, if it turned red at the top, it was positive. So you just got to memorize it. Methyl red is red. Oak Proskauer, red. Citrate blue. H2S black. Glycine dicarboxylase purple. Ornithine purple. DNase clearing. Urease pink. Gelatin hydrolysis liquid. Phenylalanine deaminase green. Catalase bubbles. That's the one where you smeared it on the slide and you added hydrogen peroxide. Blood agar, hemolysis, whether it's alpha or beta. Remember that? Kleibler's iron agar, variable. So there's different results, different positive results. So I will come back and talk about that when I go over the PowerPoint. Coagulase, solid. Nitrate is also variable. I'll come back and I'll go over that later as well. Oxidase purple. We didn't actually do this one if you remember, but you still need to know the result. As I said, it never works. You still need to know it. Bioluminescent brown, Snyder, yellow. That's the one we just inoculated. Snyder test. So it's just a matter of memorizing it as well as the negatives as well. Any questions about that? What does a positive reaction indicate? So you need to know what a positive reaction looks like. Yellow, red, bubbles, but you also need to know what does that indicate. For example, bubbles indicate the enzyme catalase is present in that microbe. Yellow in the PRG indicates glucose was fermented, for example. Okay, so I already told you this. Positive result here indicates fermentation has occurred. Positive result for indole means indole was produced. Indole was produced. Methyl red, and some of this is going to be redundant on the PowerPoints. Methyl red means mixed acids were produced. Mixed acids were produced. Different types of acids, basically. This is all stuff that microbes are doing. Biochemistry of microbes. Methyl red, positive result means mixed acids were produced. Brooks-Proskauer positive result means that neutral end products. Neutral end products. Brooks-Proskauer. Citrate means citrate was utilized. Citrate was utilized. Citrate test. H2S. H2S was produced. Black precipitate means H2S was produced. Positive result is black. What does it indicate? It means H2S was produced. Lysine decarboxylase, purple, means lysine was broken down. Lysine was broken down. Ornithine, ornithine was broken down. Positive for DNase means DNA was broken down. Pink for the urease test means urea is broken down. Urea. U-R-E-A. Urea. U-R-E-A. Gelatin hydrolysis means liquid positive result means gelatin is broken down. Notice hydrolysis broken down. Oh, no, gelatin broken down. Other tests. Positive for phenylalanine deaminase means phenylalanine is broken down. That's not that hard to remember this stuff. A lot of this. The catalase, what does bubbles mean? It means catalase is present. I have that on the review sheet itself. The enzyme catalase is present. Positive for hemolysis means hemolysis occurs, whether it's alpha or beta. Hemolysis, red blood cell destruction, right? Partial or complete or none, but none would be a negative one. Variable, we'll get back to that for coagulase. Coagulase, if it's solid, it means coagulase is present. The enzyme coagulase is present. Remember, I'm going over what a positive result indicates for all of this. Coagulase is present. Nitrate, I'll get back to that. Purple oxidase, cross it off. Just know that purple is positive result. I won't ask you anything else about it. Just know that's what the result is purple or the color change in oxidase. Bile escalin, brown means bile escalin, means escalin was broken down. Escalin was broken down. And then yellow for Snyder, presence of lactobacilli or streptococci. Awesome. The presence of lactobacilli or streptococci. Do I need to repeat any of that? Any questions? Okay, number 5. Know whether a color change is due to an acid or an alkaline environment. That was, I already gave you, it was just for the PRGs, the PR, phenol red fermentations, acidic, and then the urease one, alkaline. That's all you need to know. Okay. We already wrote that down on the table. I'll show you. You already wrote that down. That was the acid. This has to be an acidic environment to cause the yellow color. And the urease, pink, is the alkaline. That's all you need to know as far as acid and alkaline. Whether a color change is due to an acid or alkaline. So that's just for the phenol red fermentation and the urease. Know all the tests that you use to determine your unknown bacterium. This already alluded to. You just need to know all the biochemical tests. I'm not going to distinguish and say which one did you use for this unknown. Just know all of them as the biochemical tests. Okay? That make sense? Know how to measure a zone of inhibition and read the antibiotic resistance / sensitivity table on page 373 in the lab book. Let's go to the lab book. It might be on a different page actually. Yeah, it is. Antibiotic. Does anybody know what page that's on? Exercise 7-2. What? 397. And let's go to 398. So I already told you that how I was going to test you on this, I think. Let's look on 398, the picture of the Petri plate with the ruler and the antibiotic disc. Remember, Kirby-Bauer is a disc diffusion test to evaluate an antibiotic, sensitivity, resistance. You need to measure a zone of inhibition. On the test, I'm going to give you a photograph of a Petri plate with antibiotic discs on the plate with zones of inhibition. You're going to have a ruler sitting next to you. You're going to need to measure one of the zones of inhibition in millimeters. We already did that. The one in the picture there looks like it's about 29 to 30 millimeters. So make sure you know how to measure in millimeters. It's the diameter. Then you would take that measurement and you would go to a table like the one on page 400 showing the antibiotics. I told you I will have a table. It might not be this exact table in terms of the antibiotics, but it's going to be exact in terms of the layout. So if chloramphenicol was the antibiotic that we were just looking at, 30 millimeters would make that microbe resistant or susceptible. Susceptible. Because 30 millimeters is greater than or equal to 18. You're not going to have an intermediate measurement. You'll either have a resistant or a susceptible measurement. You're going to need to measure the zone of inhibition, go to the table, tell me whether it's susceptible or resistant. That's what's going to be on the test. Any questions about that? Any questions? Okay. Know how to read an enterotube and assign the 5-digit code corresponding to the test results. Let me come back to that. What does antibiotic resistance mean? It means when a microbe grows in the presence of an antibiotic. When a microbe grows in the presence of an antibiotic. When a microbe grows in the presence of an antibiotic. That's resistance. Know the difference between antiseptic and disinfectant. You already know that. Antiseptic, vegetative cells, something kills vegetative cells on living tissue. An antiseptic kills vegetative cells on living tissues. Living tissue. Vegetative cells on living tissue. Disinfectant kills vegetative cells on non-living objects. Vegetative cells, non-living objects.
What's vegetative cells on that one?
And now, the enterotube. Let me go to the PowerPoint to show you this. So let's read this again up here. It says, know how to read an enterotube and assign the 5-digit code corresponding to the test results. There's an enterotube. I had this in lecture a while back. First of all, you need to know what an enterotube is. It's a device for rapidly identifying species. Rapid identification system. Fairly rapid. Rapid identification of species using test medium. That's what an enterotube is. Remember, the test is going to be mainly one-word answers and maybe a few very, very short answers, like 3 or 4 words. There might be 2 or 3 multiple choices on there. Remember, it's mostly recall. So you're not going to have full-blown definitions on there. You still need to know what it is. Terminology is so important to understand. So let me just refresh your memory what we're looking at here. You have the enterotube here, and this is an enterotube. Old, very old. It's so old that all the media pretty much has been dehydrated. You can barely see it in there. Right? These are individual chambers that used to have media in it. On the picture up there, all the wells have the media in it, and it's full. Did I show you this before? This thing? Well, the way you do this is you take off both ends of this. This is the handle, basically, right there. There's a handle on this side. This is the point on the other end. You would inoculate, or you would get an inoculum of your sample, a patient sample, whatever, on this side, and then you'd pull it through. So you'd be inoculating each chamber. You pull this thing all the way out. I'm not going to do it because sometimes it's hard to get it back in there. Just pull it all the way out. Whatever's on there is going to be inoculated into each chamber. And then you put these back on loosely so there's air can get in there still. But that's an enterotube. These used to be all the rage years ago. Now we have more modern techniques. How do you know what you got? You have to read the results. Inside each chamber, you have different media: glucose, medium, lysine, ornithine. These are the different tests. A lot of these you should recognize. This is a code right here in red that was generated from these results from this enterotube. This code 32161 happens to be Enterobacter cloacea. How is this code determined? This 32161. 32161. You basically add up all the positive results. Each test is already assigned a number. I don't know how the numbers are assigned initially, but they're assigned a number. So the glucose test is assigned to 2. If it's a positive, you include the 2. If it's negative, you don't. So if it was negative for glucose and gas production, see the bracket includes both. If it was negative for both of those, it would be a 0. If all the rest of these results were as is, the code would be 02161. If all these 3 tests were negative, but all these remained the same, it would be 00161. If glucose was positive and gas was negative, then it would be what? 2161. Okay? Everybody with me? So, on the test, I'm going to give you this exact figure. When I say exact, I mean exact. Meaning Each of these numbers are going to be there. You don't need to memorize these numbers. They're actually going to be circled just like they are because I was unable to edit it. And I didn't want to recreate this. And what I will do is I'll give you a hypothetical list of positive results. So I might have the list next to this, and I'll have glucose positive, gas negative, lysine positive, ornithine positive, H2S negative, and so on and so on and so on. And then you just have to add it up. So if I had glucose positive, gas negative, what would it be in the first one? 2. If I had lysine positive, ornithine negative, H2S negative, what's this one? 4. If they were all positive, what would it be? 7. Right. And so on. Notice VP doesn't have anything. Don't worry about it. That's it. Now, you're not going to tell me an actual species. You're just going to give me the code. Any questions about that? Any questions? I will finish up. Wait, hold on one second. Let me just see if there's something I really should get to now.
Confused the crap.
Yep, just a little bit. I'll just finish this up next time we need it. Okay? Any questions you have that you didn't get to, you wanted to ask us now for the lecture, please ask.